Good morning, everyone. So today we want to focus on the future of numerics. Before we do that, we want to quickly review something that we approved, I think, on Tuesday on the metrics stuff. Who wants to talk about this?
Yeah, I thought Chris was going to join, but I can go over it very quickly. So basically, this is the last piece that hooks up all of the metrics work using configuration, and he hadn't implemented that at the beginning. So in the proposal, he basically just copied the model that we use in logging. So that's the upper snippet over there. But then after actually implementing, so yesterday he was able to finish all the implementation of the configuration side as well. And then he realized that because of the way that metrics work and the difference between logging, it makes more sense to just have that change in the bottom. So essentially, instead of having those two APIs in the top, we would only have that one in the bottom, which just has like a listener name. And that's basically all that it's needed in metrics. So yeah. And again, like Noah looked at it, and he did say he agreed that this makes sense because in metrics, you don't need all of the stuff that you need in logging. And so yeah, he said that this made sense.
Can you remind me why logging needs the type? You know?
I honestly don't know. I don't know if Tarek knows.
Why logging needs the type?
Yeah, I'm just trying to get a feel, like, because it was designed to be close. It was like, would there ever be a similar name?
I mean, like, logging needs the type because it can support that. I mean, you can have that in the configuration. You can specify the type name, and you can bind to this type name through logging. But in metrics, we changed it a little bit. I mean, from logging. So we don't do exactly the same, but we support like the listener name, which is like used by other properties. So we don't use the type really. And this binding will need the listener name. So we cannot in the current design with the metrics. I mean, we cannot bind to type name because like it will be like a static. We need to have the listener name. So in short, about like, there is some difference. I mean, like between logging and metrics in this regard. Chris is here also.
Yeah.
Sorry.
And what type in logging is iMetric listener configuration factory most close to?
It's a iLogging filter configuration factory.
Okay.
Something like that.
I'll try to find it.
It looks exactly the same.
Except for now, the new proposal doesn't have a type where apparently logging does. That was my question before you got here, is like, why does logging need the type?
Because logging uses it to... logging can identify things by full name or by an attribute on them that has an alias. And we thought both of those were silly, and I've never seen anybody use them, so we just said, here, let's put the name on the iMetric listener as a property, and then they can just pass in here. They can inject the factory themselves and say, give me my config. I did a sample write-up in the email. I can show you.
I pasted in the comment your last reply to me, Chris.
Yeah, great.
Yeah.
Oh, is that what's right above here?
Yeah.
In fact, Stefan, if we can scroll up for just a second, it'll show you the original logging type.
Emo, can we scroll up a little bit?
This is what it used to be.
There. See those? This wasn't my last response.
That was in the issue, the last response.
Okay. That's not what I sent to Tarek.
I see.
I will paste it in the chat instead.
So are there any concerns with this change? I just want to make sure that we give Tanner his time back. If not, we can push this to next Tuesday. If there are
I
any
think
concerns.
it's fine personally. It was just a question for my own education.
There you go, Stefan. There's a longer write-up in the chat.
Yeah,
Excellent.
Okay, awesome. Thank you so much, and thanks again, Tanner.
Yeah, if you have any concerns, Stefan, we can follow up offline.
Yeah, I don't
Thanks.
think they will be, but yep.
Thank you, folks.
All right, thanks everyone. All right, then Tanner's issue.
All right, can you hear me?
Yes, we can.
Awesome. So the basic premise here is that we have historically provided a range of support for numerics processing. We've consistently improved that over time, particularly in .NET Core. One of the areas where we are still missing some core functionality, however, is in supporting basic AI processing and tensors. We had previously experimented with the system numerics tensors package, which was experimental and never shipped. We still have a desire to expose that moving forward, but in a shape that accounts for the needs of the community, our first-party customers, and more recent innovations in .NET, including static virtuals and interfaces, the new numeric types, generic math, etc. For .NET 8, in order to support some of our first-party customers, there's a desire to expose a subset of that support in an out-of-band package that targets .NET Standard. This is namely pulling various APIs needed and that are currently exposed internally for ML.NET, as well as others such as semantic kernel. And so the basic premise is that we would start by providing, just in the system numerics tensors namespace, a class, a static class called tensor. This would eventually have a partner type tensor of T, and it would follow the general pattern of what we do elsewhere where a generic type is involved, such as for vector and vector of T, where the generic type exposes the operators in the core instance operations, and the static class exposes additional APIs that are either for a specific type of T, which are better exposed as instance methods, or which help provide driver-like functionality for the backing generic type. Could you scroll down, Mo? A little bit further. down to the proposal. Yeah. So the basic premise of these APIs is for .NET Standard, we're not going to have the concrete instance type because we don't want to restrict ourselves with the inability to version it to support things like generic math. However, there is still a core set of functionality that is exposed and supported across the entire programming ecosystem across many languages, which is in the form of a set of APIs that were originally defined in the BLAS and LAPACK libraries, which functionally operate on arrays of data directly. And so the tensor type would expose the support for that for float, which is what's needed down level. And it would expose it over span. These would be the driver APIs, and they would be what the tensor of T would end up making much friendlier to actually invoke when we later get around to exposing tensor of T itself. But these are functionally the primitives that are exposed across all the ecosystems that support the linear algebra-like APIs. The one that they follow the fairly standard pattern that we have for other span APIs. The one deviation is instead of returning an int, which indicates the length, it returns the span, which allows them to be used in expressions without users having to manually reslice the span each time. And particularly when you're doing things like arithmetic, many developers do not want to have to split their APIs across explicit separate expressions in order to achieve that functionality. And so returning the span still gives you the length, still is optimizable as if it had just returned the length if that's all you need, but otherwise allows you to use them in compound expressions. Core set of functionality required is the basic arithmetic operators, the core combined operators for add multiply and multiply add, and then a core set of logarithmic and hyperbolic transcendental functions for the operations that operate effectively just over an array. So they perform the operation efficiently over every element in the input. Any questions so far?
What are the, like, let's take the first add. Are left and right, do they have to be the same length? Does it do things if they're different lengths? Like, what is the relationship of destination and the return?
So left and right have to be the same length. It doesn't make sense to, and most places do not allow you to have different lengths. The destination is the destination buffer. It has to be at least as big as the input, but it can be larger. The return is destination, but sliced to the number of elements that were actually written into the array. So if none were written, it would be it would just be destination slice 0. And if 15 elements were written, it'd be destination slice 15.
Well, presumably you mean 0, left dot length. That it's always slice 0, left dot length.
Yeah.
Yeah. Not if it wrote 15 things, it'll return skipping the 15, their first 15 things.
Yeah.
I'm not sure how I feel about the fluentness of the return span. That's just returning the destination span as the result.
It's returning it sliced to the written length.
Yeah, I mean, like, I can agree that, tensor of t dot add should return a tensor of t, but I think that my personal stake is that these primitives should follow our rules, and if somebody wants to make it fluent, they can write a wrapper on top of it.
Okay. I didn't have a strong preference there. Just it's what several other spaces do. But if we want to say that the intended use case is to use tensor of t in that scenario, that's fine.
Yeah, I find it, I understand the goal and it makes sense. I just find it confusing because I have to really think through, like, okay, this is returning to me a span. Does that mean it's allocating something, or what is it returning to me? Oh, it's the destination. Oh, but it's sliced, and I'd find it a lot easier if it was just.
Yeah, and as long as
either void or, yeah, I guess I would expect void.
Just that the caller's supposed to know it would return left.length or right.length because they have to be the same.
Right.
Yeah, that'd be fine too. Because assuming that all of these are the destination, that they would always return left.length, or x.length in the case of the trig functions, that basically you should just pre-slice destination to be the right thing and keep using your destination buffer as the expression. I mean, I guess you can't write a expression tree if it's not returning, but yeah. Like you wouldn't, if you already know the slice that destination is going to be, you wouldn't be slicing over and over again anyway. So, but yeah, I feel it should follow an existing pattern, not make up a new one.
Okay. And then the other thing to call out here is that for the second overload of the APIs, the T right is effectively broadcast to the length of left. So it's an optimization when you're wanting to add the same value to every element in left, without having to allocate, which is a very common thing, both for hardware support and for the actual core BLAS specification.
That's basically broadcast, right?
Right.
Yeah. For x blog cosine sine tangent, is x does that show up elsewhere? Is that a name that we use in other APIs, or where did x come from?
That is the name we use in our math APIs, which was likely originally done back in 2000 because x is the formal term that you use in math when defining a function over something. It's just the default variable used.
If we weren't naming this based on that, what would you choose?
You'd end up calling it values most likely.
I mean, yeah, I'd probably go with values instead of x.
Even though that's inconsistent with what we used for generic math.
Well, this is a promotion of the scalar to the vector, so it should pluralize, and x's is not a thing that, it's a thing everyone can say, but no one can spell, so values.
Right, but if you're conceptualizing this as a tensor, it would just be called tensor. Just like you would just call an array an array. Hence, it is still a singular input.
Fair enough.
I don't have a strong preference, just I went with X because that's what we've used in all of our other APIs, and that's what also gets used in the similar APIs when you look at like system numerics vector. Although sometimes we use value and sometimes X depending on the API.
It looks like in math we sometimes use D as well. decimal D, double D.
Yeah. I think there's a couple that are float F, which was taken from C.
Do we have an add multiply anywhere else? I would have thought there would have been one on intrinsics, but I'm not finding it.
No. The reason why so multiply add you typically have as fused multiply add because you're doing it with one rounding. This one is not a fused operation in that sense. However, it is different. It is slightly different from calling add and multiply separately in that it will iterate over the input. It will do one loop rather than two loops. And so it's more efficient because it walks memory once rather than twice.
Yeah, I was just looking for consistency in naming.
Yeah.
Because multiply add did go with left, right, and add end. And so I was looking, what did we call it for other add multiplies? But if we don't have anything.
Presumably all the ones that take T should be off T, or is the T should really be a float?
I didn't think, yeah, that should be float. I just, I had started by writing the spec out for the generic math version and then extracted out the subset that was needed for the net standard package. And I guess I forgot to replace those T rights with float.
Okay, that makes more sense now. Okay, so they're all just float, singular floats.
Yep.
Yeah, as for the bottom 5 on the screen with X or value or values or whatever, I don't super care. I do see that in negate we called it values, and by calling them all values, we're at least consistent with the sort of unary operations.
Mm. Yeah, notably negate ends up being values because it's the named version of the operator, which for other APIs we didn't use X. If I had my own preference for X blog and others, I think X is a little bit clearer, especially when you get down to some of the vector arithmetic ones below, like cosine similarity. Because those take two parameters, X and Y, and there aren't de facto names for those. If you're looking at the mathematical algorithm for it, you'll look at X and Y. When you look at something like atan 2, for example, which also takes Y and X, you then also want atan to be just X for similar reasons, because they're comparisons of each other, and if one was values and one was Y and X, it'd be potentially more confusing. But that's not a strong preference. To answer Frederick's question from YouTube, is float the correct primitive type for non-generic tensor? .NET usually would use double, no, but float as a primitive might be a domain-specific default. Machine learning and AI is domain-specific, and they almost exclusively use float for the actual computation. .NET historically did only expose double operations back in .NET Framework. Largely because the hardware at the time only had the by87 floating point computation unit, and that was 1 bit width, 1 register bit width, which is 80 bits, and you could only set one rounding mode, and changing that rounding mode was expensive. But for machine learning, it's basically exclusively float that you want to use for perf reasons. And so the down level partners need float for the future where we'll have a tensor of T type that will support float double or half, as well as any other custom defined IEEE based floating point types,
And so you don't.
and potentially other concepts like bfloat.
So, but I mean, why would we not do the same API service for floats and doubles on this type? Just because we don't
it's
need it,
more.
or?
Yeah, this is to fill in a first party customer need on net standard until they can make the migration to modern.net. And so it's basically, we could expose a lot more here, but we're trying to keep it as slim as possible. And if they do come in with an ask because it's out of band, we can always add those APIs. But while there's not a need, there's no point in doing the excess work.
I mean,
for .NET 9, the intent would be that the equivalent functionality is exposed for all T via generic math in whatever shape makes sense. But it could end up, we could choose that we add overloads of all these APIs that are just generic on a T that's constrained to I floating point, whatever. But for right now, the immediate need for incorporating AI into applications, working with vector databases, it's all float.
And so how should I look at this type? Because you drew an analogy earlier between vector and vector of T, but vector, the non-generic one, still deals with vector of T. It's just that it's kind of like typed over the abstract, over the static methods rather than being as part of the type. But this one here doesn't really have a type, but you just deal with spans. And is the intent here really, it's because we just don't have the type system support we wish we had with generic math and .NET Framework, so we have this kind of duct tapey type that gives you the operations, but in the future on modern.NET, we would recommend people using the tensor of T type because it works nicer. Is that kind of...
Right. So if we were only supporting .NET Framework, if we were only supporting modern.NET, we didn't have to care about .NET Framework at all.
Right.
Then we'd probably have all of these taking tensor of T, etc. However, since we need to support .NET Standard, and because these are basically the algorithmic forms of the APIs that operate over raw data rather than over type data, it makes sense to consider, even if we were only targeting modern.NET, it would still make sense to consider exposing them, just because it allows users who have their own tensor types to still do these core primitive operations in an efficient way. You can almost consider this to be like, these are like, if we were to expose BLAS directly, then these would be the signatures that would be exposed for BLAS, much as system.math exposes the C runtime math APIs effectively directly.
Right. And that's kind of what I'm heading at. Is like, we can either treat this as the low-level type that just gives you the hardware accelerated operations, and then it's up for higher-level libraries like tensor of T or some other third-party thing to just have a nice type for it. Right. This is just the workhorse. Versus this is just the duct tapey solution for .NET Framework, right? I mean, these are kind of the two extremes that we can take. But it would control what we would do moving forward, right? Because if we treat this as the low-level type, then I would expect us to keep adding functionality to this tensor type for all the primitives that we think are relevant, versus if it's just a duct tapey solution for now, then I would kind of expect this to just support float, and then, all the other types would just be part of tensor of T, right?
Right. The difference being that for net standard, it will be float. And then for modern.NET, the plan would be we still expose the same signature, but instead of exposing double, we expose T where T is I floating point.
You would do this on this type or on tensor of T?
Yes. Yes. On this type, and tensor of T would defer down to that workhorse implementation. We need the workhorse anyways. We need it separated out to avoid the generic code explosion for the runtime, etc. So you still want all of the APIs to be on this type, and it's basically just taking what would have maybe been an internal implementation detail and exposing it as exposing the actual workhorse implementation for everyone to use, because it's such a core primitive of these linear algebra based operations.
But then even in that world, if we were to decide that, oh, we really want double for .NET Standard as well, then all we would have to do is just do what we do here, just have dedicated methods that just deal with double. And then, on .NET 9, you can actually write generic code that just uses the T. But, if you're in that standard, you can still write float and double. And worst case, you have to do the typical if T is type of blah trick. But you could still make it work if you wanted to.
Right, and that's still consistent with how we've done it for vector, for example. There's some APIs like ceiling and floor, which aren't supported on any T. They're only supported on the floating point types, and so we have the explicit overloads of them. And then we've also got the generic form that's correctly constrained in some other cases where you want to support the API in a generic context, and where you don't know the concrete type to be used. So we have a mix of both depending on what's necessary for the API in question.
And then for the tensor of T type, I don't remember the API service, and I don't think we ever actually looked at it, because I think we just only showed previews of that. So would the intention be that on this tensor type, eventually we would have methods that also take tensor of T? Or is that kind of orthogonal? Like this would only deal with spans here?
This one would likely only deal with the spans for most of these, such as for add, subtract, multiply, because with tensor of T, those would be operators instead. For something like exp, we may end up wanting to have we may end up having an API here that takes the that takes tensor of T directly as an overlay read-only span once, because you want to be able to do tensor.exp passing in the value rather than tensor of T.exp and passing in the value, because then you don't have to specify the generic type.
Right. Yeah, I'm asking because we haven't really looked at tensor of T. I'm just concerned that we might, depending on how final we think that API service is, we might find that, I don't know whether there's any implicit conversions from, tensor of T to span or the other way around, that you might find yourself with ambiguities. Yeah. But if you don't want to
we don't
mix them,
we don't consider it final at all. We're going to take a holistic overview of the type and bring the entire thing for proper API review for likely for .NET 9. It's just not required to look at it for the for what we're going to be shipping out of box for Net Standard.
Yeah, I think in general, like it's not that. So I don't object to anything you're proposing here. It's just I have a slightly uneasy feel of saying we ship this first and then we ship the hero type, if you will, later, because it's just, abstractly speaking, does this design do anything that corners us for the hero design later, right? But if you already have a pretty good handle on what you think the hero design ends up being, and we're pretty confident that it doesn't conflict, this is just the low level / down level version of that type, then I think I'm fine with that. I just want to make sure we don't hamstring ourselves.
Yeah, and in particular, the biggest issue would be if we had implicit conversions. But this is a case where you don't want an implicit conversion from tensor to span or vice versa, because there's potentially additional metadata that would end up being lost as part of that. A tensor can be multidimensional. A span can only be single dimensional, for example. And so it'd be similar to the concept of implicitly converting a multidimensional array to a span, which we don't allow. Right. It's unsafe because you lose the additional bounds checking.
Yeah, you have to know what you're doing at that point. Presumably that's the same here, right? You basically say, like, you have to unroll this thing in memory in your head, basically, right?
Right.
Who is the customer for this? Do we already have one using it?
We will.
It's going to be,
Yeah, I was going to say.
Go ahead, Stephen.
Semantic kernel currently has a subset of this defined, and we'll be removing it from semantic kernel and then just referencing this library. ML.NET also has a subset of this defined as internal helpers, and the intent is that most of or all of its CPU math internal class gets deleted, and it depends on this library. But then after that, it's expected that a significant percentage of folks that are trying to add copilots to their .NET applications will need some subset of this functionality, in particular, like cosine similarity there at the bottom, because you get back, you make a request to whatever your vector database is, you get back some number of already filtered down vectors, or not filtered at all, depending on what your database is, and then you need to compare that against your embedding, and so you need a function like this to do that comparison.
I know this is a low-level API, but is there any benefit to like separating the element-wise and vector arithmetic into like different namespaces? Like looking at multiply, people might think that's like a cross product because it's like beside dot and all that, but I don't know.
I don't think so.
Standard.
These are, some other, depending on the API in question, some other ecosystems give it a different name. For example, multiplication of the span by the t is called scale in several other scenarios. It's still a multiplication, but some places call it scale instead. But for things like cross product, the standard name is to call it cross or cross product. Whereas multiply is the element-wise multiplication.
For add multiply and multiply add, it looks strange to my eyes that we have right followed by addend or multiplier. Should they all just be either addend and multiplier or multiplier and addend?
That's not what we did with things like fused multiply add. I think that ends up being potentially more confusing. When you have it like this, it follows a consistent convention of left and right are the thing that you end up doing first. So you would end up adding left and right for add multiply, and then you've got the third thing that's happening as the explicit named argument.
I guess, I mean, I don't feel strongly about it, but it seems to me like if I'm calling this, I need to look at the third argument to say, oh, the third argument is addend. Okay, that must mean the second one is the multiplier.
Right, but that's there's, I don't think there's an easy way to specify that no matter what you do. And when you're looking at something like it, I think the issue is, if you're doing something like addition, you don't necessarily have a name for both left and right. Some places use the term augend and addend, but augend is not super common, and I think it'd be more confusing for users than otherwise.
Left addend, right addend, and multiplier, but just as suggesting some terms. Yeah, I mean, I think that the add multiply and the multiply add are basically, once it's doing two things, you have to look at the docs, and the docs will say it does something like returns element-wise left, or open paren left plus right close paren times multiplier. You're like, okay.
Yeah.
Would it be clear if it was add then multiply and multiply then add?
That's then inconsistent with what we've already exposed elsewhere.
Well, I think elsewhere we've only done it for the intrinsics, right?
And system.math and generic math, because fused multiply add is a general purpose operation.
Okay.
With a standardized naming of multiply add.
And these aren't fused.
Yeah, these are not fused, which is why there's no fused on the name. Blaz notably calls multiply add AXPY for A times X plus Y.
Yeah, let's not do that.
Can you tell me what Blaz or LAPAC or the Intel instruction set calls cosine similarity? Because I cannot find it.
I don't think that one is formally part of Blaz. Cosine similarity is the name, and it's what will show up if you there's a Wikipedia page on it if you just Google it.
Right. Well, the things I'm looking for are what somebody else would have called the parameters, and then seeing if their definition is cosine similarity or cosine difference, since they're inverses of each other.
Mm. Yeah.
And making sure that we're using the name that goes along with the math that we expect to be returning.
Yeah, in this case, it's similarity. Whenever you're looking at the mathematical algorithms, they use A and B or X and Y. And even when they're inverses, like for cosine and arc cosine, for example, the standard term is just to use X for both.
It's not weird that we have left and right everywhere, and then we switch to X and Y for cosine similarity.
I don't think so, because with addition and subtraction, there's very clearly a left hand and a right hand side of the operation, since they're binary operations. For something like cosine similarity, it's a complex algorithm for which there is no left or right. It's doing, products, summations, division, square roots, and many other things to do the actual computation.
Guess I don't see the distinction being made. Still, I mean, we basically just choose left and right from the notion of it being operators. And if there was a cosine similarity operator that returned a float, you'd still have a left and a right.
Well, yeah, but you wouldn't have such an operator. This is like because this isn't a binary function with a left and a right side. This is a function that takes two inputs. So it's more like an unary operation that takes a tuple.
I don't understand why.
Because it's not an operator. I don't know how to explain.
I don't know how it's
that.
different from like equals in that regard.
Well, equals is also an operator.
That's my point.
Right, but equals is a binary operator that has a clear mathematical symbol defined, where the way you'd write it mathematically is a left side, the operator itself, and a right side.
Right, but all of these are all operations taking two inputs and returning a result. I guess I don't know
right, but
why it matters how complex
there's
the implementation of that is.
Because there's a difference between a binary operation and a function. These are not binary operations because there's two inputs. They are a function that takes two inputs, which makes it distinct. It's like a tan 2, where it is a distinct mathematical function, and there is not a left and a right. There is technically a numerator and denominator instead.
I guess I just don't see the distinction here. There's two inputs. We're arbitrarily choosing names for them, left and right, X and Y. It just seems like it's inconsistent on the same type to be switching between them. I don't think the depth of analysis that's being applied to decide to go with X and Y instead will translate to most consumers.
I
just
don't
seems
see why
strange.
not, and it's how we've done it everywhere else in the BCL. The distinction is really just if it's an operator, there's a left and a right. If it's not an operator, then it's a function, and functions don't have a left and right.
Well, all the methods that are defined above are not operators. They might have corresponding operators, but they're not operators. They're functions.
Yes, and the Framework Design Guidelines recommends exposing named versions of operators to support languages that don't support operators, and that's
and
what
it
these
supports
are.
naming them something other than left and right.
Does it?
What does it say?
Well,
That you should name them for whatever they would be called if it was a function. So for division, it's things like quotient, or divisor and dividend and quotient, right? It says name everything as to what they are, not where they would be in an operator.
interestingly, I don't think there's anywhere we've done that.
Right,
We've
and
always
when
just
I
used
brought it
left
up
and
in
right or
generic
X and
math-
Y.
Yes, and when I brought it up in generic math, your answer was, well, that would be inconsistent with what's actually been done in math before, so let's not ignore that, or let's ignore that rule. And so we did.
Oh, we didn't expose named operators called add for generic math, notably. We explicitly avoided that.
Where is there any example, Jeremy, where we do what you just said?
I don't know. I'll find the section in FTG and see if it references either we wish we named it this way or we actually named it this way. But I know it suggests, like I'm pretty sure I can find it with the word quotient in FTG.
It just seems to me like, regardless of what we've done elsewhere, an individual type should really be consistent. And the fact that there's a whole bunch of functions here that are taking two inputs to be operated over, and some of them are left and right, and some of them are X or Y, just doesn't make sense to me.
Yeah, I guess I can get behind that.
I don't know how to. Yeah, I don't
I
know
heard
how
your
to
argument, Tanner. I
convince
just
you
don't
that
agree
it
with
makes
it.
sense to me. Yeah, yeah. I'm probably not going to agree with yours from. To me, it does make sense, and it's then consistent with how we've done the other ones. But different people can have different opinions, so we'll just, I guess, as a whole, need to come to a decision on what we want to do, and then we'll just do that.
Yeah, sorry. Consider meaningful names for operator overload parameters if doing so adds significant value. It weaseled its way out like 4 times.
I mean, for math, usually it's pretty obvious left, right, X, Y, right? They're semantically almost the same. Like, at least assuming you know the operation, like plus, minus, and all of that, people, I think, understand what X and Y would mean there. I think some of these operations are a bit more tricky. They take multiple parameters, in which case it's kind of important to know which one is which.
Yeah. So big integer div rem is dividend, divisor, and remainder. Big integer divide is dividend and divisor, not left and right. Add is left and right.
To be honest, though, I'm not sure in those cases it actually helps that much, because I have to kind of look up what these words mean.
Sure.
I mean, it's not like generic English that you're just, I know exactly what a divisor is.
Right. So, I mean, but yeah, so the sample it gave in the book, and then I looked to see if it was wishful thinking or reality, was big integer divide. And so big integer divide did get named parameters instead of just naming them positionally.
Right. Although I think for binary operators, like, I mean, if the order is not left and right, I mean, what the heck are you doing, right?
Because the best I could come up, like, especially if we take the complex case, like multiply add, right? It would basically be add int 1 and add int 2. Sorry.
Sure.
Multiply add, it would be multiplicand 1, multiplicand 2, and add int. And
I
that
think it'd
might
be
make me
multiplicated
happy.
multiplier in that case.
Yeah.
Fair enough. Okay. But yeah, it's just it starts being one of those like, yeah, there are like 6 people in the world who look at it and go, oh yeah, that was the right name. I agree with Steve's meta point that it's weird that we have left and right and then X and Y as other different placeholders, which seems just like maybe left and right for things that are super common infix binary operators, and then cosine similarity instead should be, you know, vector 1, vector 2.
I think that's so I personally think that vector 1 and vector 2 are significantly worse names, because it makes explaining that in it makes explaining what the operation does in the remarks or the summary significantly harder. Having the single letter name when you're trying to explain what it does is significantly easier. And so if we were to do something, I would prefer us just to do X and Y everywhere, because then you can just have the remark say performs the operation element wise X plus Y, or performs the element or performs the operation element wise open paren X plus Y times Z. So you can make it very clear what each parameter name does without having to make it overly long, without having to worry about translating it into other languages, etc. You just have a clear mathematical definition of what it is.
So how do you feel about X, Y, and add-in for multiply add, Steve?
Fine. Wait, for
What about
which one?
just X, Y, and
multiply
Z?
for what?
Multiply add. So this would be if we take all left rights and replace them with X, Ys. Does that would be locally consistent? Would it be...
I like the locally consistent aspect. I don't have a strong opinion on left, right versus X, Y.
Would it be X, Y multiplier or X, Y, Z?
The fact that one of them
X, Y
is
multiplier.
yeah, the fact that one of them is special means I think that naming the special one makes sense.
Okay.
Okay, so we replace all left and rights with X and Y.
So can you repeat this? Are you suggesting that we replace every left right with X, Y?
Yep.
I think this was brought up earlier, but the T there in all these, those are mistaken. Those should be float.
Yep.
Yeah.
Okay.
Yeah.
Looks like Intel, who, as we've discovered, aren't the best at naming things. They think add takes A and B.
So
Yeah,
much worse than
it's
X
basically
and Y.
always X and Y, or yeah, it's either A and B or X and Y.
Yep. And then in their explanation of what it does, it says it's I times Y1. It's like, no, you name them A and B. Like,
Well, someone
Oops.
who for his whole life ends up at the end of every list because of starting at A and B and working his way down the alphabet, I definitely vote for starting at the end of the alphabet and working our way back. So I'm all about X and Y.
X, Y, Z, W.
in UV, yeah.
Yep.
Turns out humans don't like going backwards. Like progress, just going backwards in chunks. Besides, Steve, isn't T usually where the second lineup or the second sign up line starts? You should be at the front of the second line.
In my experience, there's only ever one. kind of towards the end.
Yeah, BA gets you through lines pretty quickly. Thanks, Dad.
All right, so then after the scalar ones, we get to the vector arithmetic, and so there's a few core operations defined here. Cosine similarity, distance. For distance, someone called out and asked whether it should be Euclidean distance. I discussed below that the standardized naming is distance, and that a Euclidean distance is effectively the de facto terminology, is distance itself without any modification is effectively de facto Euclidean distance industry-wide. So it should just be called distance. A similar discussion came up for sigmoid, where sigmoid is effectively the de facto name referring to specifically the logistic sigmoid. So much so that there's even calculators that support just typing sigmoid X and it will do the logistic sigmoid. Wolfram Alpha is another one where if you look at their documentation, that's exactly what it refers to, etc. So those were kind of the two that had had questions on their names. Normalize should notably be explicitly called Euclidean norm, because normalize and Euclidean norm are two different functions. Normalize returns a vector, whereas Euclidean norm returns a scalar. Then there's dot, which is dot product. Dot is the same name we exposed on the vector APIs directly. It's the industry standard term because that's what Blaz did back in the 70s. You've got max and min, which doesn't do an element-wise max and min, but it rather returns the maximum value found. And then you have index of max magnitude, which we have functions on math which are max magnitude and min magnitude, so this functionally returns the index of the float whose absolute value compares the largest. So if you had two inputs, 3 and -4, it would return -4 since the absolute value of that is the largest.
Well, it'll return
there's
1
a consistency question
because it would return the position of the negative, not the -4 itself.
Yes. There's a consistency question on whether we should expose max, min, max magnitude, min magnitude, and then index of max, min, max magnitude, min magnitude, or not. For what's needed on that standard, it's just these ones in particular, not the full set. But longer term, we'll have that consistency question, so we may want to decide here which one is necessary. If we're only doing one, then index of is the right set to expose.
Given infinite implementation time, it seems like both the value functions and the index functions are useful. So since what we do in this meeting is more the shape, I feel like we can go ahead and say that the shapes are all fine. Steve, since you were the strongest proponent of the consistency of parameter names, do you think that these values are okay, or would you like them to go to X?
I have a small preference for X, but yeah, I mean, it'd be nice if anywhere there was a single value that was an input, we named it the same. I get that there are reasons why we might want to be consistent with something else elsewhere. It just seems strange to me, but at the end of the day, it doesn't really matter.
Yeah, if we're being locally consistent, then I'd also prefer X here.
Sounds like all single parameter or all things named value are probably also becoming X.
Then we have the sum and product operations, which are those funny E-shaped symbol some people see that they don't know what it means. It's just a for loop. But we've got sum of squares, so that will multiply every element in value by itself and sum that together. And sum of magnitudes, which takes the absolute value of everything in the input and adds them together. And we've got product, which same thing, but instead of addition, it's doing multiplication. Product of sums, so it's multiplying. It's creating a temporary. It's adding the sum, a temporary that's 1. It's taking the sum of left and right, and then it's multiplying the temp by that, and then doing that iteratively. And then product of differences, which is the inverse of sums. It's subtracting left and right, and doing the sum there. Or sorry, doing the product of those.
Yeah, those all seem fine to me. My math sense says those are running those are going to lose a lot of precision in float, but if it's what the people want, it's what the people want.
Yeah, they can potentially lose precision if you have unnormalized inputs.
Yeah, so for the bigger picture thing, and I know generic math can't express this well, so I'll ask it here. Is anybody going, like, if somebody wanted to do 2 floats and do product of sums and get back double so they had more precision, is the answer just once we have the more generic form of this, they have to upcast the float vectors or float tensors into double tensors and then call that function, or what?
Yeah. So they'd end up having to the simplest way would just be to do a link conversion. But we'd potentially also have explicit casts or convert APIs that would allow you to efficiently convert from float to double. Then you could do the product of sums as double and then downcast it back.
Okay.
And then the last 2 APIs here get into the polyfill bit. So the last 2 are convert to half and convert to single, which does vectorized conversions between float and half. And the reason these are as part of this is because while the de facto operation size, that is the data type used for computation in the actual algorithms, is float for AI and machine learning. The storage type is, especially in more modern algorithms, is typically not float. It's half, because for storage you don't need as many bits, and you can have the amount of memory you use, especially with very large data sets. In order to support these vectorized APIs, we would then need to expose as a polyfill the system.half type, which has come up basically every time we've discussed the polyfill. I think it was even in Immo's proposal for how we do polyfills moving forward like 3 years ago, and it was one of the example types of what we need to polyfill and why. So this would just be finalizing that and saying we are indeed polyfilling system.half down level in a Microsoft BCL half package, matching the API surface that originally shipped in .NET 5.
Where does convert to half live right now?
There's only scalar conversions today.
Because to me, these conversion functions don't really seem like they belong here.
Well, so if this were tensor, then it would be casting. You'd end up having this as the API that casts from tensor of float to tensor of half, and so this is the driving workhorse for that. We notably on vector of t, which is a fixed size type, or it's a limited width type, we have similar APIs of convert to double, convert to single, convert to int32, etc. So it's following that naming.
But that's converting those types themselves. Right.
Right. And the same way that the above APIs are taking in a span and returning a span or a scalar t because they're the workhorse functions, this is doing the same thing for the convert API.
Yeah, but I mean, this just seems like it's saying that what we need somewhere is just, the bulk conversion writing functions. Like it just seems it feels weird to me that they're being put here. And that we don't also, while we're doing it here, have, convert to single that takes ints and longs and decimals and right. It's just, it's a weird carving out. And so it's just this weird, to me, it feels like a wart sitting on this tensor type. And is this something that's actually like an intrinsic doing a good widening, that this is better than just the trivial for loop?
Yeah, this would end up being vectorized under the covers and using hardware acceleration where possible.
But I mean, again, it seems like that's a thing that somebody would want for move a bunch of ints into float space, assuming that the CPUs or that anybody's CPU will do that vectorally.
Right, and for modern .NET, when we talk about the tensor of T type, we'd end up having such conversions, and then you'd have corresponding convert to int32 and convert to single overloads that take the other types. But this is covering just the ones we need for .NET standard for the .NET 8 out-of-band package. So it's explicitly minified to the minimal surface area necessary.
And yeah, consistent with the things up above, that these should be intervoid.
Yeah. There's also notably not necessarily another place to put such APIs without just inventing another type to hold such conversion functions. You could theoretically envision some API for memory extensions that you could have some kind of cast API there that converts between T and U and has the appropriate constraints or whatever, or that supports explicit types. But we can't put anything on that type for the out of band package because this is going to target net standard 2.0. So we're kind of stuck with either inventing some new place to put such APIs or putting them here.
Yeah. I get just thinking of where we think it would belong. Like ignoring the read or ignoring the down level, where do we think the right answer is?
If this were modern.net, yeah, if it were modern.net only, I would say memory extensions and have this be a general purpose cast API supporting the primitives because it's not strictly tied to the concept of vectors or interpreting the span as a vector or matrix like piece of data. It's just doing a valid conversion of the elements. But because we can't do memory extensions.
So if we were just looking for the future, you think it would just be memory extensions cast of read-only span source to read-only span destination, and it would be a bulk cast operation.
Right, kind of like how we've got enumerable.cast for link.
Right.
Or is that no? Yeah, we do have a cast. You can do cast or select, I think.
Yeah, well, cast as.
Yeah.
Yeah. All right. I mean, it really was. Do we feel that those should belong on some other type? I guess the problem would be we'd either decide it belongs on the source or the destination, and no matter what, half is only one of them. And the other one's float, and we can't change float in net standard.
Well, and we can't change half either because that shipped in net 5, so we have to match the net 5 surface area.
Fair enough. Yeah. So I don't like it, but I don't have a better answer. It's like naming everything X.
And that's the last of these ones that then it just discusses the two polyfills, one of which is system half matching the net 5 surface area, which means it's effectively an interchange type with comparison and equality, parsing and formatting support, as well as the explicit conversions to double and float. That's all it supports. It doesn't support operators or anything else, which is suitable for the common use case of the data type as just a storage mechanism for AI and ML.
I thought
the other one is.
Sorry, I thought we weren't doing a down level out of band for half as part of this. We changed our minds.
I don't believe so. As far as I remember. And maybe Michael remembers if that's changed or not, but half was still, it wasn't necessarily a required type for our partners, but it was a type that they're using in various cases. It would allow them to more easily make the migration, the eventual migration to .NET Framework.
Yeah, my understanding is we were still planning on doing it.
It just feels like we're lumping something else in with, like we're using this as a reason to hook on something that we were talking about doing in the past. I'm not saying we shouldn't, I just don't, it doesn't, it feels like we're using this opportunistically to slip something in. But like semantic kernel only uses float.
Yeah.
Does ML.NET use half?
ML.NET, I believe, has its own internal half type it uses for conversions right now.
And we'll delete that as part of this?
Right, they'd be able to make all that functionality public and work across they're across both Net Framework and Modern.NET, with the ability to then allow devs to trivially transition their apps to Modern.NET when framework support is eventually dropped.
But specifically with ML.NET, there's currently a system.half, like a copy of system.half that's defined internally, and we'll be able to like literally delete all that code and just add a reference to this and use this one.
I don't think it's called system.half.
Yeah, I'm actually
Go ahead, Michael.
Yeah, I was gonna say I'm not actually positive about that. I know that it's being used in internally in Torch Sharp in a couple of places, but I'm not sure about ML.NET. I don't remember that type, but I can go double check.
Yeah, we if we don't have to, then we don't have to. My understanding is that it was still needed for some of our partners. Well, it was a nice to have for some of our partners, so not strictly required, but it would make their lives simpler. And then it's the scenarios that it's always been brought up for is specifically for our first party partners on .NET Framework for supporting ML and AI scenarios.
Okay. I thought Luis had run things down and hadn't seen a strong need, but I could be wrong. I want to make sure we're basically, we're, for the most part, we're very forward looking. We only ship down level the stuff that we absolutely have to. I just want to make sure we're being consistent with that. And I think the stuff we've reviewed thus far is in the we need to camp. And I just want to make sure that this stuff we're talking about now is also in the same camp.
Yeah, I'm not seeing a half type at all for internal in ML.NET, even like a custom one.
Okay. We can double check with Luis again then. And then I guess it would be if Luis says it's not necessary, then don't ship it down level and don't expose the convert to half or convert to single APIs either.
That sounds good to me. I'm fine going based on whatever that conversation yields. We can still
and
review
then the
whatever
other
we need to review.
polyfill.
Yeah.
Yep. Okay.
All right. So I guess then if we have to have convert to half and convert to single, is that X goes to destination? It feels like it should be source to destination, but that is differently inconsistent. Value probably is the wrong answer. That it probably either wants to be X or source.
I don't have a preference. X would be more consistent with what it would be locally consistent. But if this had been on memory extensions, we'd probably have named it source.
Yep.
You have a preference, Stephen?
I don't know.
I think I've convinced myself that I have a slight preference for source since it's convert to and not an operation in the sense that the rest of the things on this type are operations.
I was gonna say something similar. This is obviously like directional in its nature. There is, going from one thing going to something else, and there's a translation happening, but at the same time, I don't have a good reason why that differs from, tangent or sine, which are the same thing, going from one thing with a translation going to something else. So I don't care. If it were an extension method, what would we call it? source, right?
Source. And I mean, we could say that for, sigmoid being it does an element-wise thing of source into destination, and I think it's returning span of float, but should just be void now. Like that could also, we could say that source and destination are consistent with doing that kind of operation.
But that's my point, is like a bunch of these are of that ilk, right? That you scroll up, there's tan H, cosh, sin H. They're all similar. I don't know.
Right. So it may be all the things that were, I guess we can argue it any way we want. The converts, I feel, should be source and destination. The other things, I don't care if they're source or X.
I think with the other ones, I'd much rather them be X, because that's then consistent with the other operations.
Yeah.
With convert to half, I think we can argue that we may we can argue several ways. Like, if it weren't for net standard, we'd be putting this elsewhere and we'd call it source. It's doing something that's not necessarily a mathematical operation where all the others are clearly mathematical ones, etc. So I think keeping the others as X and then having the convert ones being source is
fair enough.
Maybe the best.
Yeah.
Sounds
I
like
mean,
a reasonable.
and the super best is that we don't need them at all. But I think deciding on the name while we're talking about it now sounded better than bringing it back up later.
That sounds reasonable. I think keeping the rest X, and for these, I think both source and X are justifiable. So either's fine. If Tanner and Jeremy prefer source, then sounds good.
Yeah, I'm only like 52-48 on source, but I'm not actually ambivalent. So
yeah, I'm mostly ambivalent. But with a preference of, I don't think things like max or tan should be source.
Yeah, that's fine.
So the just convert where source is considered then?
yeah, so convert to half and convert to single are source and destination.
Yeah.
And then
It was
everything
brought up
else
earlier,
is
but
in
I think
terms of X.
these all of these things that take a destination throw if destination is too small, right?
Yes. Otherwise, they'd be try APIs. Try some.
It's a fun name.
Mm-hmm. It's delicious.
All
right, so I think everything that was
Hyper-
returning span is now void. All lefts are X, all rights are Y, and all values aside from the bottom two are X.
That sounds right.
And then for min and max and magnitude, so you showed min and max and showed index of max and min magnitude, and I think we said we should just go ahead and approve squaring this off, and so we'll have max magnitude, min magnitude, index of max, index of min, and the index of blank magnitudes.
Yeah, I think that sounded right. The consideration was that for index of max magnitude and index of min magnitude, the way that they actually get used is you need the index rather than just the value. And there's some scenarios ultimately where you need both. If we were to only expose one set, then index of is the one that allows you to do either set, because you can theoretically implement max as X access index of flaw. But overall, if we expose both, I think that allows slightly more efficient implementation, just like with contains versus index of.
And then
So
I'll ask this as a naive question. Are the max and the index of max the same hardware instruction that we're just reading two different answers out of? And if so, should we be returning something more complicated like a value, comma, index tuple?
no, so there's at the hardware level, at the hardware level, you end up having to iterate over the whole thing. For Max, you have to iterate over the whole thing, and then return that value, because NaN also comes into play. And with index of, you actually have to track which index rather than which value. So you basically have an extra branch inside of it.
I mean, because the index one needs to know what the value is because it needs to know if it's bigger. Like the max one can
right.
Forget the end, and that's why I was asking: is it really the same hardware instruction? And it's like they write the index into the B register and the value into the A register, and then really we should just say, well, we got both at the same time. We should give both at the same time. But if it's not actually that way, then definitely don't do the thing I was proposing.
Yeah, there's no hardware instruction to track the index. It basically just does it per element. And so what you'd end up doing is you would end up doing a vectorized max across the entire. You'd get a vector 128 containing 4 floats, which are the max, and then you do a horizontal max to determine what's the maximum of those 4. So it's basically vectorized everywhere up until the last 4. And then it's a scalar operation to determine the maximum of those. And then for half, I presume that there's no issues with the API surface, assuming it is needed, since it's exactly matching what we shipped in Net 5. Just the first time it shipped.
That sounds like the smartest plan to me.
And then the other polyfill.
Go
ahead.
No, just because it presumably the package and it would make a Net 5 target and say that it is type forward.
Yeah, I believe that's how we'd end up having to do it. The other polyfill would be system.mathf, which would be in a Microsoft BCL mathf package. This is one where it's so let me think of how to phrase this. Exposing system.mathf down level isn't strictly required. However, we end up having to implement the entire surface of system.mathf in order to implement this tensor class. And other libraries like ML.NET have their own version of mathf. In ML.NET's case, it's Microsoft ML internal utilities mathutils. We also have our own down level copies of mathf in some other places, in some of our own libraries in the BCL. So it's a question of, do we want to go ahead and provide that since we have to implement it anyways? Or do we want to have yet another internal copy and not expose it, and everyone will just need to continue maintaining their own internal copies?
Isn't this, regardless of whether we want to or not, isn't this one of those cases where something in CoreLib also exposed as an out-of-band package? If we ever add anything to it again, we've basically locked we can't augment the OOB. Am I remembering that correctly?
That's already the case. Yeah, that'd be the case, and that's already the case with MathF because the surface has changed since we shipped it in .NET Core 2.0. So we can only match the .NET Core 2.0 surface area, which is notably what's needed for the down-level tensor surface here.
Yeah, it's probably true of all types in a Microsoft.bcl package that they can never gain surface area at the net standard 2.0 TFM. Eric, you have a question?
So
yeah, I had a couple quick questions. So this is a static type. So if we really wanted to oob additional API, we could always toss it another static type. That wouldn't need, we wouldn't have the benefits of type forward in that in the future. But if we really got ourselves in a pickle and wanted to oob some more methods, we could do it that way. The other question I would ask, which is one that Michael and I were looking at yesterday, is like, can we actually implement this in a way that our users would appreciate? Because I think we were noticing that all these things are implemented by directly calling the opcodes for the backing methods on the CPU, and we wouldn't be able to do that in a noob, and we wouldn't be able to convince the JIT to call. So would implementation be casting to double and using existing APIs?
Most of these aren't implemented by hardware. They're calling and deferring down to the C runtime. So we'd end up implementing this as a P invoke into MSV CRT, which is all we have to care about for Net Framework.
I see. And we have all the methods that we need in the CRT to do this with the signatures.
Right.
The only one we looked at yesterday was square root, which we saw was CPU instruction.
What would happen if someone ended up with that package on Linux, with that asset on Linux?
On Linux, we can configure it to P invoke into CLib on Linux. We know how to do that, but if we were to support Linux, that's what would have to happen.
Is the tensor type going to be inbox?
Eventually.
Yeah. So I mean, I guess the tensor type itself would be a question, but any of the MathF functionality that would unify, because Linux, all .NETs on Linux have the right minimum version.
Yeah, my comments weren't about the tensor type. My comments were about MathF.
Yeah, so MathF I don't think would be a problem on Linux because it would just type forward to the other MathF, which I think would be in all supported versions.
But you can still end up in a situation where you get the net standard 2.0 asset and end up using that as part of your application.
Can you? Because by the time you get an application, it should have pulled the net core asset, and then that would say it's a type forward.
Yeah, we don't have runtime asset selection for this, and an app. Yeah, if you hit that case, we probably tell them, hey, you've got to reference the package in your application, and you have to make sure your application targets the runtime that you're running on. The cases where you use the wrong asset are cases where you didn't reference the package and you got it transitively, or cases where you referenced an older framework than what you're running on. So I think in both of those cases, we would probably tell people to target that newer runtime.
Isn't it super common to get an asset transitively? Like, you're not listing every single package in your graph as part of your CS
it's not. Yeah, so packages do flow transitively over project references and over package references and are resolved for the framework that they're used in. The only case where you don't do resolution for the framework you're referencing is old packages config land. That was one of the big things we fixed with NuGet 3 back in the day. That's why packages were brought into the build, is so that they could get this transitive flow and resolution specific for the framework of the project.
So what would be an example? how would someone end up in the situation where we would use the workaround that you suggested of having them explicitly added to the CS project? What would their configuration look like to end up there?
Yeah. To a library that was targeting that standard too. We see it a lot with really old, crusty internal build systems like CoreXT, where they're not using package reference. Yeah, it's not. We already say that if you do this, you're not in supported territory. We could take this offline if you want, but yeah, I think it's viable to say that we don't need to support Linux in the net standard implementation, and then just make sure we have a nice error message in that case that is SEO. I mean, otherwise you build a runtime PAL, which I don't think it's work, but I don't think it's work we need to do. So,
okay,
I got to step away for a second. Sorry.
Yeah. So as for the packaging on this, like you said, this would be like Microsoft BCL Tensor, and that there would be Microsoft BCL MathF, and like, why isn't just Microsoft BCL Math? Why aren't they all in one package?
Because that's not how IMO had the polyfill recommendation set up.
I think we may have changed that in the last couple of years, because now I think we look for all the crypto stuff now is Microsoft BCL cryptography. We don't break it out by when we added it and what the specific feature is, and this is the bucket for crypto things. And we collapsed a bunch of networking into Microsoft BCL networking, and we're going for not the one everything bucket, but not like a bucket per type.
Okay, if that's the case, then should we just include them in System Numerics Tensor package? Or is that problematic and they need to be in a Microsoft BCL for polyfills?
My gut says the polyfills should be in Microsoft BCL, but I note that the PM for this feature is being awfully quiet.
I would assume that as well. Emo's often somewhere else, but
I'm here.
I would also I would also assume we would do all the new stuff in System Numeric Tensor, DLL, or new NupKeg, and anything that we were polyfilling, if we decided to polyfill them, would be in Microsoft BCL dot whatever.
Right. I mean, that's the pattern we have used. I mean, I'm not sure that's the best pattern, but it's the pattern we have. I mean, I think the business case makes sense to me. Like, it's the concern that I mostly had in the past was around adding it to .NET Framework, right? But that's never going to happen. So on core, it's pretty straightforward. I think if we really wanted to, we could make the type replaceable, but that would mean we can't put it in corelib, which I don't think we want. So I think we want to put it in corelib, at which point we would just say, sorry, it's inbox at some point, and we either do what Eric is suggesting, we just put the method somewhere else if we really want to oops some more methods, or we just live with the fact that, at some point, it is what it is for dawn level.
Sorry, now you're talking about the tensor type?
Well, in general, like, I mean, this kind of depends on
because MathF is already in corelib, so.
Right. So, like, that's, I mean, yeah, we have the option for everything new, right, regardless of where existing stuff lives.
Notably for MathF, it's going to exactly match the surface area that exists on Math for double. So even if we theoretically needed to polyfill other APIs, we'd then have the question of, well, what about double? So I'm not too concerned about other APIs beyond the core set that Net Framework was already providing.
Emo, in your post, it looks like instead of adding to min and max, you removed from min and max.
I removed from min and max? What do you mean by that?
I see you have max min and index of min.
I don't think I changed any of that.
Somehow you lost index of max.
Maybe it was one of my bulk edits that went south. So which method is it again?
So you have index of min magnitude, and definitely index of max magnitude should come back. And then we talked about squaring off the feature. So have
Oh yeah.
4 index of methods and 4 min max methods.
I see. I know what happened there. So we said 4. What are the other 2?
So max, min, max magnitude, min magnitude, and then all 4 of those with the word index of in front.
So these guys here or these guys here?
Both.
I'm not
So-
sure. Okay.
So max and max magnitude, min
Yes.
and min magnitude, and then index of those 4 things.
Gotcha.
So right now we have the numeric max and min, and we have the index of the max magnitude and min magnitude. We want to square off the feature.
So you want a method called max magnitude and min magnitude.
Yes.
And then also, so basically that's like 6 total now. Max, min, max magnitude, min magnitude, index of max magnitude, index of min magnitude. And then we also have index
then-
of min and index of max.
Yes.
Gotcha. All right. I think I have it now.
Modulo details.
I guess we have to return float from those.
Max
Maximum.
magnitude, min magnitude should be float, and the index of should be ints. So your floats and ints are backwards on the middle
Yeah.
two.
Copy pasta for the win.
Yeah. So I don't have feelings either way about whether MathF should become polyfill public as part of this effort.
Yeah, there's like I was saying, it's not strictly required. We can keep it internal, but we ourselves have in the BCL itself have like 3 or 4 different polyfills already. ML.NET has its own polyfill. Semantic Kernel has its own polyfill, and the community's also been asking for MathF for, well, ever since it first got introduced. So I have a slight preference towards just doing it since we're needing to implement it all anyways, but it's not necessarily a strong preference because we could still achieve what we need here, keeping it internal.
So what is the downside if we put it in the package and we type forward it? I mean, it's an existing type. We know how to type forward it. It just means the API service you expose for NetStandard 2 kind of has to be frozen based on what we already have.
And in fact, it's frozen in the past of what we already have, I think Tanner said. We've added to it since we introduced it.
Yep.
Yes, you cannot exceed what was introduced in, let's say, NetCore 2, right?
Yep.
With the
This
types
is
already
exactly
in box.
what got shipped in NetCore 2.0.
So, but we can statically verify that is correct. So we can convince ourselves that we have that. It just means you can, it's not even that you have one shot at it. Like, it's already predetermined what the API service can be. And it's just a function of like, do we do it or not? But like, it's a kind of a binary thing. There's no evolution of this type.
Right. But so for me, the question would be, are ML.NET and the tensor package going to be able to use just what's here, or do they need something we added after this type was introduced, at which point they already have their own partial
Right.
polyfill, and having a full private copy is probably better than having a split between private and public.
I mean, unless these methods do something that they can't
So-
do, but yeah.
Right. The other benefit is that it means that because they can normalize on the single implementation, they will end up getting the type forward on .NET Core or modern .NET rather, where things like abs or square root will get intrinsic recognition and emit a single hardware instruction rather than a call to the C runtime. And for the calls to the C runtime, they will be suppressed GC transition effectively because they're F calls. So they will also have less overhead to invoke them. So there's benefits to having that polyfill in terms of perf and normalizing everything.
Yeah,
Normalizing
again,
what I
it's
want. I don't remember the word I want.
but if like half of what they want is on MathF as of Net 5, and they're still going to have to do this, then us making this part public means they have to go do a bunch of gymnastics to deal with it. Assuming they
Notably,
name
we've not
MathF.
added. Notably, there's not tons of APIs we've added since there are things like QBrute and ACOS-H, so the inverse hyperbolic from the hyperbolic that were exposed in in the original Net framework. They're not particularly prominent, and as far as I see in ML.NET's math utils class, they're not there.
Okay, so you think they could entirely replace their thing with this MathF?
Yeah.
Or almost all of it.
Yeah.
Fair enough. Yeah, I mean, in that case, it sounds like it would be used and that there's needs. So sounds reasonable to me. I don't know what the process is these days, but the intent seems viable. And was this the only thing that required? That is the quote unquote required polyfill? Because half is going as an offline discussion.
So what is this? What does it do
Yeah.
with half? Like what?
Half was if there was an open question on whether semantic kernel and ML.NET actually needed half or not.
Gotcha.
If they don't actually need half, then we won't provide it down level. If they do actually need half, we will.
Yeah, that makes sense. If we don't have customers, what's the point?
And unlike MathF, we don't have to go implementing half internally ourselves to provide the other functionality.
Right. And so for MathF, what's the conclusion? We check more what else they need, or are we saying we're not going to do it?
I think we leave it up. Tanner will go talk with Luis, and they can decide together whether we're going to do it or not.
Okay.
Yeah.
But we are cool
so-
with Tensor going down level, right? That one.
Yeah, that has to happen.
Okay. So then the discussion is really about the other types. In terms of API servers, there's nothing to do here, right? Because it's basically we can oob what we have. Like it's an upper bound. Right. I guess the same holds for half as well, right? So it's more if we do it, we do it.
Yeah, the only question for MathF and half is what package or packages do they go in if they go down level? Is it Microsoft BCL MathF or just Microsoft BCL Math, and we just shove all the math things in the one package?
I would do the latter, because they're all in the same versioning bubble anyway, right? So it's not that they're on the same versioning bubble per se, because we introduced the types of different versions in the platform, but we know what those are, and we can if them appropriately, but they are effectively the same feature, right? Just the feature over time, if you will.
But Tanner, you said there's also another possible existing package they should go in, or no?
No, so I was asking if it should go in the system numerics tensors package alongside the tensor type. But I think you said since one's a polyfill and one's not, the polyfill should go in their own.
Yes.
If rather than Microsoft BCL Math, should we call it Microsoft BCL Numerics, which is maybe numerics is the name of the namespace. We have system numerics, blah, in a few cases like system numerics vectors was an out-of-band package. This will be system numerics tensors. And in this case, if we do have half and mathf, then numerics is a little bit more encompassing.
I would agree with that. I mean, the one thing I'd say is like I would not put types into packages that are fully OOB that we have to type forward. Like, well, once you have a package that is type forwarded on some versions, I think you can put in whatever other type forwarding you want in there, because basically it prevents this assembly from being pure OOB, and at that point it doesn't really matter. You're already halfway pregnant at that point, so you might as well stay in that world. And so in that way, I think system numerics is fine, because you would just say this is the home for anything you're going to ship out of band and type forward.
You mean Microsoft BCL numerics?
Yeah.
Yeah, okay.
I think the question becomes for tensor. I think tensor, like what I haven't heard really, is like the type would be inbox, but technically we wouldn't have to type forward it, right? It's probably cleaner, but we wouldn't have to.
Right, because when we eventually add TensorFT, it will be in the system numerics tensor package, but it will be in the inbox package. And so it will effectively become like system.memory is, where you've got the down level package, which is now frozen in time, not changing, and any new functionality is just inbox provided by default, and you don't have to reference a package.
So if tensor is expected to go inbox, because I assume it's going to go in core lib and get special love, should it just out of the gate be in Microsoft BCL numerics? And we say this is not we don't want people to reference the package. We want them to just get it with the platform. But if you're stuck on Net Framework, then there's a package. Because that's what the Microsoft BCL prefix really means. It's we don't think you should be using this, or we think you should move to a newer version of the platform. This wasn't intended to be distributed via NuGet. It's just a thing that we're doing because we're nice.
Is that fine for Net 8, since we'll have a Net standard and Net 8 version of the binary in the package?
Why wouldn't the binary assets just be in private or system private core lib in Net 8?
Because we've already locked down for RC1. So one of the reasons why this is going to be
of the
benefits of it being out of band is we're not tied. Yeah.
So none of these are intrinsic. So none of these are intrinsics in 8. They become intrinsics in 9.
Well, the 8 would have a type forward for mathf.
Sorry, but I mean the stuff on tensor.
For Net 8, tensor's implementation can use vector 128, vector 256, 512 in its Net 8 asset. And on Net Standard 2.0, it can use vector of T.
Okay, because it wasn't adding any operations we haven't already added. Well, it had the add multiply. But if nobody has a CPU that's already intrinsified that, then I guess we already wouldn't have had it. So, if they had done it, we would have already had an intrinsics and we would have had a naming pattern. So they don't. So we don't. Okay. Yeah, if it's going out in 8 as full OOB, then calling it. Then I guess I don't have an opinion. Like if we think long term, the package is dead in 9.
I don't know that it is.
Well, it could gain new types, but the types can't gain new members.
Well, that's not even true either. Like we ship system text JSON in NetCore app, and we ship it as an OOB, and it gains new things all the time. Where it becomes a problem is when we then type forward that down to something else.
Yeah, we can evolve things where the OOB layering and the inbox layering is the same, and we can replace the assembly wholesale. We can't do that when things overlap with inbox assemblies like corelib.
Okay, so it's as long as the type stays.
Right, but if you know, we could bring system numerics tensors in at just above corelib, and system.link could depend on it, and whatever else.
Right.
And we can still evolve. Yeah.
Okay, so in that case, naming the package that has tensor system numerics tensor makes sense to me. Just somehow in my head, this was core enough that it needed to be a corelib, but it sounds like because it'll be based on vector, so it's allowed to cross out of the corelib boundary. Okay.
I mean, that's my ideal. It's possible at some point. Well, I'll be wrong, and it's possible Tanner's going to say you're wrong in .NET 9, Stephen. But at least my idea for it is there's no strong need right now to make it be in corelib, and it can continue to evolve. And until such a point when it can't, anyone using the SUSE system numerics tensor package will just get any additions for free.
Right. The current consideration is we want to bring this in box. There's potentially some long lead items that we want to bring about for that could involve runtime or language integration. So the tentative goal is 9 or 10, depending on what the total sum of the 3 teams decides is feasible and achievable within one of those time frames.
Right, but none of the things that you're planning for the tensor utility functions type or tensor of T, to your current knowledge, requires merging it into corelib.
Correct. We can achieve everything using the APIs that are already exposed from corelib, like system runtime intrinsics, until a point at which we add some runtime feature, which means it has to have intrinsic recognition in the JIT or something like that. And I don't think there's going to be a case for this type.
Okay. Yeah, I guess I assumed since it was you and it was numerics that it was corelib, even though I think I'm the only one who ever said that word. So say a system numerics tensor for the should it be system numeric tensors? Package names I feel like are collective or mass nouns. And then the polyfills be Microsoft BCL numerics. Like tensor is the name for the type, but I think the package might want to be tensors.
I don't have a preference on that. I think the existing we have an existing experimental package, and it is let me see what it's named. It's tensors. Yeah, the existing package is tensors.
Funny it about the 11:10. I thought we were wrapping up, and I was like, we didn't need the full 2 hours, but
I thought the same.
Then I talked more. I'll just blame me. All right, have we answered everything?
I think so.
So then I guess the conclusion is you would approve what I just posted, right? And then we would maybe add a note and say for math F and half. We will follow up offline.
Yeah, I mean the bottom two members are contingent upon the decision that half does need to go down level. If it doesn't, then they're cut. But
Yeah, I think that goes without saying. Otherwise, it wouldn't compile. Sweet. Should we call it a day then?
I'm gonna stupidly ask just one extra question. The title says System Numerics Tensor, but I think the proposal said System Numerics Tensors Tensor. Which one's correct?
That's a great question,
Whatever namespace we currently have.
I think you put it
So-
in tensors.
Tensors Tensor.
Is that where you put the tensor type? Tensor of t? And does it
Yeah,
matter?
it's
I guess.
system numerics tensors.tensor.
Okay. So the title's wrong, the proposal's correct.
There's enough
I-
stuff in
I-
tensors. Yeah, there's like 5 types in there already. Tensor. Yeah.
Cool.
Yep. All right.
I move to adjourn.
Sounds good. Then I see you guys on Tuesday.